The other type of inheritance is implements. Now, implements works in a different way. Implements, as I said, is just a matter of having an interface, and then I say that I'm implementing that interface, and that interface is the same for all classes that extend. Because I could, if I don't fully implement an interface, I guess I get an abstract class, which do exist in Java as well. But most of the time, what I want to do is, of course, I say that I'm implementing a particular interface, and then I'm implementing all the methods in that interface. So let's create an interface. Let's do an interface for FizzBuzz. Basically what I do is I just list the methods, and I could have some attributes here, but in particular I just list the methods that should be available. And the interface for a FizzBuzz is to have a callNum method, it should have a list method, should have a count method, and it should have one more count method, and I have the debug out method as well. Like so. And because I add print stream here, I need to import that as well. Now we can go to the FizzBuzzer class, and I can say that I implement this. Like so. And because I had all of those methods, I had the callNum method, I have the list, I have the count, and I have the other count, and I have the debug out method. I am fulfilling all of this interface. So that should work. And let's go back to the start class and see what I can do, because now I can basically say that here FB1 can be of the type FizzBuzz, which is the interface then, but I can't create instances of an interface. I have to create instances of a concrete implementation of it. So this one will still have to do a new FizzBuzzer, like just that I can call it, I can put it into a variable of the type FizzBuzz, of the interface type. And then if we go up here, and then I need to modify, or I don't need to, but I want to modify all of the methods that are using a FizzBuzzer to say that I am in fact just using the interface. Like that. So now, if I run this, I have the same functionality, nothing has changed there. The only difference is that I am now in my start class not using the actual implementation FizzBuzzer, I'm using the publicly available interface FizzBuzz. As you notice down here in the main method, when I created the last FizzBuzzer, down here. I didn't bother about changing the type of this variable fb3. It's still a FizzBuzzer, but since FizzBuzzer is a FizzBuzz, it will get upgraded, if you will, to a FizzBuzz object when I call the test FizzBuzz, and it's going to be used as a FizzBuzz. Technically it's a downgrade because I might lose functionality there. All I know it has at least the methods in a FizzBuzz interface. It may have more. And if I want to use this, I can create a new type of FizzBuzz. Let's call it a word buzzer. Which works almost like a FizzBuzz, but not quite. You'll see the difference as I go along. It's still in the example package. I can be lazy here, and since it's only the print stream that I want from there, I implement the same interface. That means that I need to have those methods. I'll come back to that. I want to have a number of words that I can use as count words. Like that. This is, by the way, yet another way of initiating a Java array. I don't need to put the new string array here. I can just give it like this. This is a static array. Static, not in the sense static as in a class, but it's an immutable object. It's here and it won't change ever. Okay, and then this class is very much modeled from the FizzBuzzer class. So let's put that side by side so we can copy paste. This one I'm going to need more or less as it is. I have my calls and it's on a list, and but it should be a word callout instead. I have a constructor. I have a default one which just adds two alternatives. Like so, and I have the other constructor where I give it an array of elements. Like so. Now let's go into the interface. There was a call number method which I need to implement. What I want to do with this one is make it into something that can be used with words instead. This one I have to have, even though it takes an integer in. What I want to do with my word buzzer class is that I want to actually be able to call num with a string. So of course I need to convert this one then. I'm going to be lazy about it and just say that take the number modulo the length of my array of count words, and whatever word I end up, that's what I'm going to actually be calling. And what I want to do here is more or less the same thing as in the call num method that I had in the fizzbuzzer. Using the Streams API again. If I match the string I get in, that's what I'm going to return here. And with those that are left, I am going to get the callout for that one. And then I'm going to put that together into a string again. And whatever I have now is either nothing at all, or it's a string that was a match, so a fizz or a buzz or something like that. And if I don't have a fizz or a buzz, just return the number as it was given to me. And then there are other methods that I'm not actually going to change. So the methods that come now are the same as they would have been in the fizzbuzzer class, or as they are in the fizzbuzzer class. But since I can't put the implementation of them in the interface, I need to copy paste. So this gives me a certain amount of duplication of code. The list method is the same. I create an array list and I basically append everything, and I make a string and return that one. Count does the same, and the count with the print stream does the same as before. This one is slightly different, because I have word callouts instead. And a word callout is so different that I can't reuse the callout I had, and I can't inherit from it. So I need to make this as a separate class, which is unfortunate, but sometimes that's life. So I need to write that class as well. But as you notice, I'm going to copy the structure from the callout class. It's just that since I'm changing one of the parameters, the number from an integer to a string, I need to create it as a new class. I can't reuse that much. The match method basically will do a string match instead. And now what I'm going to do is I'm going to check if the number I give in contains my number. And that's the match function I'm going to do here. Actually, these methods, the get callout and the set callout and the toString method, I can copy paste, and the only difference is that here I'm going to say that it's a word callout. Oh yeah, I haven't actually created an object of that type yet, so I'm not actually testing anything yet. I've just created the methods for it. Let's do a printout again. Like so. So I'm creating a new instance of my new class WordBuzzer. I'm using the default constructor that will create the fizz and the buzz for me. And I'm putting that into a fizz-buzz object. So this is the interface that I implemented, if you remember. So this should be fine. Create a new test object. With the WordBuzzer. Compile and run. It does help, of course, when you actually write the keywords or reserved words, and if you spell them properly. There we go. We start the test with word callout down here, and I'm counting 0, 1, 2, fizz, 4, buzz, 6, 7, 8, 9, and because 9 doesn't contain the actual word tree, or 10 doesn't actually contain the actual word 5, this one doesn't work as well as the number-based fizz-buzz, but that was besides the point, really. I mean, the point was to show you how to work with an interface. So there you have it. We have worked with implements now, and as opposed to the extends. What have we learned now? We have learned that we have the two different code words. We have extends and we have implements, and we have regular classes and we have interfaces. We have learned how to use the... Actually, these are just elements in my list instead. We have used the super keyword to get at the superclass. We can use super to point to the super object and then call a method on the super object. And if we want to call an object on ourselves or call a method on ourselves, we can use this. This is implicit in most cases, but sometimes it helps to actually make it clear. We created an array in a new way. And we actually gave a mutable array in a different way again, where we said that we had like that. We've used the override keyword. It's case sensitive, so you have to spell it with a capital O. It's not strictly required, as I say. It's something that helps the compiler and you to read the code, and you get help from the compiler to actually catch misspellings and those kind of things. We've talked about lazy includes or lazy imports. Where I use an asterisk instead of actually specifying all the different classes that I am importing from that package. Use it wisely. It's always better to be more explicit, but if you're using a lot of elements from a certain library, it cleans up the code if you just say I'm using stuff from the Java util library, for example. And that takes care of inheritance, the two different types of inheritance in Java.